Dr. John Lenters is an associate professor in the School of Natural Resources at the University of Nebraska-Lincoln, as well as an environmental consultant with Limnotech Incorporated in Ann Arbor, Michigan. He was born and raised in Holland, Michigan, and has worked previously at Lake Superior State University and the University of Wisconsin-Madison. Dr. Lenters' research focuses on the effects of climate viability and change on the Great Lakes and other water resources such as rivers, soil moisture, groundwater, and snow cover. This includes a Lake Superior monitoring station on Granite Island near Marquette since 2009 to measure weather conditions over the lake, as well as the impacts of climate and ice cover on lake evaporation. These results are being used to help us understand how evaporation may be contributing to recent low water levels in the Great Lakes. Dr. Lenters will be giving us an overview of current and anticipated climate change impacts in the Great Lakes and St. Lawrence Basin. Dr. Lenters.
All right, thank you for that introduction. I guess I should start off by saying it's appealing that apparently the meteorologists are no longer getting blamed for the weather. It's the mayors on up to the federal government. So don't kill the messenger here, I guess, is part of the story. What I'd like to do is give a relatively quick overview of background on climate science and what it means for the Great Lakes region. And I've got a lot of slides here. I'm going to go through them pretty quickly. It's not meant to be comprehensive in terms of all the impacts, but what I want to do is give you just sort of a flavor of some of the things that we're seeing and the things that we can anticipate with climate change. So just quickly, the outline for my presentation. I'll be going over some of the information sources, not only so you can see where I'm pulling the information, but where you can go yourself to get some of this information. And then talk about a little bit about the global climate science and the climate change issue, as well as regional local impacts. So there was a report that came out in 1997, Adapting to Climate Change and Variability in the Great Lakes St. Lawrence Basin. This was based on a workshop in Toronto. It is 1997. Some might claim that some of this information is out of date. On the other hand, a lot of it is not. And there's a comment in this report that I thought was very relevant. It says, the climate change issue is so multifaceted, so far-reaching and complex that no single discipline can answer all the questions and provide all the needed expertise. And that's, to me, that's not meant to be a depressing statement. It should be an inspiring statement where we recognize the fact that we need a lot of expertise, not only in the sciences, the physical sciences, social sciences, but also folks out in the community and the cities and the governments. So very complex issue. And of course, one of the information sources is provided by the Intergovernmental Panel on Climate Change. This is a group that doesn't actually do the basic research, but they do all the research on the research. So they dig through all the peer-reviewed literature and pull together all the information that they feel is most needed to assess the current climate and the current trajectory of climate change. There's been a series of reports. There will be a new report coming out in about a year, and you can go to the website to pull off a lot of this information. The U.S. has the Global Change Research Program. They have climate assessments that come out every once in a while. They have a new one that's now coming out. It's in draft form. I'll be showing some of the material from that. Canada has a similar report. The latest one that I was able to find was in 2007, and I'm sure they'll have more coming soon. There's something known as the Great Lakes Integrated Science and Assessment Center, a collaboration between Michigan State, University of Michigan, with funding from NOAA to look at specific impacts within the Great Lakes region. So global climate change, a quick overview. This is probably the best way to explain the difference between climate and weather, but climate is what you expect and weather is what you get. And this is just an example of, what an ore carrier might expect out in the Great Lakes at a given time of year and what they might actually run into. So there's a distinct difference between weather and climate. And so it's not really, you don't talk about weather change, you talk about climate change. And what we expect is what's changing. Well, of course, if what we expect is changing, that also changes the boundaries of what can physically happen, and that does change specific weather events. So in other words, in some ways, we have to expect the unexpected. Things are likely to be warmer, they're likely to be wetter in general, but we're also likely to get more extremes, more variability, and more drought. And that might seem counterintuitive, because as I just said, things are likely to be wetter, but you can have wetter and more drought at the same time. Expect the science to evolve and improve, and cities should plan for long-term change, adaptation, and mitigation. And the key there is long-term, not that we aren't going to experience extreme events that may occur in very short time periods that are related to climate change, but we need that long-term perspective. It's essential. And on the left, we just have, sort of a histogram that shows the variability in temperature that you might expect and the shift that you might get with climate change. Sometimes you just get a change in the mean, but sometimes you get a change in the spread, and so the extremes become more common. And this could be shown for temperature, precipitation, many different atmospheric variables. So what we expect is changing. You've probably all seen these kind of curves before. CO2 is going up, temperature is going up. The most rapid changes have been in the last 30 years or so. You've probably heard in the media that there's been kind of a leveling off lately. For the most extent, that's really not true. I mean, climate change is a long-term trend, and if you look at the short-term variability, you can fit 5-year curves within there that are going up and down and up and down and up and down. The latest leveling off is no more of a leveling off than we've seen in previous decades. So talk to me again in 30 years, and we'll see if that's a leveling off. Not only are the changes not uniform in time, they're not uniform in space. This shows the trends from 1900 to roughly the present, and you can see that the greatest warming has occurred in the northern high latitudes. This has been expected. It was predicted for quite a while, and it has to do with the reductions of snow cover, enhancing the warming effect. So what does this lead to? Well, it can lead to increased heat waves, and I pulled off some specific examples for the Midwest U.S. and around the Great Lakes region. Days above 95 degrees Fahrenheit will go up significantly. We have an example here of the 1995 heat wave in Chicago, which was quite devastating. And you can see the projected increases in heat-related deaths for 2 different climate scenarios actually match and exceed the 1995 event. So what that suggests is that 1995 will become the new normal in terms of heat waves. And unless we adapt to that and specifically mitigate the problems that might occur with that, we're going to have some serious problems on our hands. Longer growing season, so the frost-free season has been lengthening. It's predicted to continue to increase. This can be a good thing. It can also be a bad thing. And an example shown here is the actual change in the ragweed pollen season that has been lengthening through time by up to a month in some regions. Changes in energy use. So we get increased cooling degree days in the summertime. And this is an example for Ontario that shows the energy demand from current to 2080 with significantly more energy use during the summertime and reductions in the wintertime. So there's adjustments that will have to be made to be able to meet these seasonal shifts in the energy demand. There's warming of the world's lakes. I'm helping to lead a project where we're looking at some of the most rapidly warming lakes in the world. And this was a project done by some collaborators using satellite data to look at where the lakes are warming most rapidly. Turns out the Great Lakes are one of those regions. Also Northern Europe and the Southwest US. These blocks, the reds and the oranges and the yellows indicate warming lakes. There are a few that are cooling, not really in a significant way. But we're trying to look at this data more carefully to see what the mechanisms are. And this is an example for Lake Superior. It's one of the most rapidly warming lakes. It actually went through what you might call a step change in 1998 after a very warm 1997-98 El Nino winter, and has largely not recovered from that, jumped up by about 3 degrees Celsius. The ice cover in the Great Lakes has been declining. We all know this. Some examples are shown there for Lake Superior in the satellite imagery, and the decline is significant, from 30% average ice coverage down to about 10%. And this is not only true for the Great Lakes. This is ice cover data from Lake Mendota that goes back even further. This is in Madison, Wisconsin. And you can see that the lowest events are certainly more recent in time. So this is leading to lower Great Lakes water levels. And this is an example of Lake Michigan Huron reaching record lows this past winter. The blue line there is the actual water level. The green is the record monthly low. And we know that evaporation and higher water temperatures is contributing to this. How do we know this? Well, we actually have measurements now of evaporation just 20 kilometers due north of here. There's an island called Granite Island, and just north of that, there's a lighthouse called Standard Rock Lighthouse, where we have instrumentation that's actually measuring evaporation rates. And just to show one example, this 2010-2011 winter in this chart was a warm winter, low ice cover, or the preceding winter was low ice cover. We had warm water temperatures that subsequent summer, and this is accumulated evaporation rates for that year compared to the previous 3 years. And you can see that by the end of that year, we had 25 centimeters of additional evaporation because of the earlier start to that evaporation season. And 25 centimeters might not seem like a lot, but the issue with climate change is that in 30 years, that might, again, become the normal. And if we're evaporating an additional 25 centimeters every year in 30 years, that adds up quickly to significant drops. These are the Lake Superior monitoring sites. Granite Island is a collaborative project with Northern Michigan University here in Marquette, and the project at Standard Rock is a collaborative project with Environment Canada and University of Colorado Boulder. And we're expanding this Great Lakes evaporation network to include the other Great Lakes so that we can continue to monitor the impacts of climate change on evaporation and water levels. So what I'd like to shift to here is just the question of global warming. Is that really an appropriate term? You may have heard this said in somewhat of a joking sense, but it's really not joking. Some people have said, well, what about global weirding? And they're totally serious about that. And I think that that is actually a better word because things are getting stranger. And there's a lot of strange things that are a result of climate change that cause people to think, well, it must not be happening because these are contradictory. But that's not the case. It's just a complex science, and we're still trying to wrap our brains around this. Here's an example. Most of you are probably fully aware of the fact that the Great Lakes are dropping while sea level is rising. And you're probably aware of the reasons why that's very different. But a lot of people in the public don't understand that. Well, sea level is rising for a very different reason. The oceans are warming. Anything that warms generally expands. So the oceans are expanding. They're also getting more runoff from thawing glaciers. So sea levels are rising while the Great Lakes are falling because of different reasons. And so the projections are that sea level will continue to rise because we know it's related to changes in temperature. Snow cover in the northern hemisphere has been declining. You can see rises in sea level in other locations. This is near Prince Edward Island. And so this is observed. It's predicted to continue to occur. It's well understood because it's related to temperature changes. Now, of course, as sea level rises, that leads to other problems, particularly storm surge vulnerability. As the sea levels increase and you have storms come in, there's significantly more risk of erosion and storm surge. And the St. Lawrence is one of those regions where it's highlighted here as being significantly vulnerable to these 40-year return periods. Sea level rise is predicted to occur at about up to 1 to 4 feet by 2100. All right, so these projections are going to continue. And here's another global weirding example. A lot of times you'll hear people get confused when we say that, oh, there's more snow this year and it's related to global warming. Oftentimes you think of, more snow is contradictory to global warming. It is in fact not. As the climate warms, you get more moisture in the atmosphere. And we still get winter. So if it's 10 degrees below freezing or 20 degrees below freezing, it doesn't really matter. It's still below freezing, right? So if it's going to precipitate, it's still going to be snow. And so if there's more moisture in the air and it's below freezing, you actually get more snow. And this is occurring in some regions, particularly the Great Lakes. There's actually been a documented increase in lake effect snowfall, partly for the reason I already mentioned, and partly because we've got less lake ice, and so a longer ice-free season that leads to the lake effect snowfall. And this is a map showing regions to the north where we have had an increase over the last 20 years in snowfall. You look to the south, and it's actually been a decrease in snowfall. All right, so a bit of a conundrum. Another one I'll point out, the Arctic. Arctic sea ice is declining significantly, and people think of it, oh, it's just the Arctic, it's way off there. Unless you're really concerned about the polar bears or what's going on up there, maybe we shouldn't really care. We should. There's something known as the Arctic Oscillation or the North Atlantic Oscillation that impacts weather in the Great Lakes region. We actually had a fairly cold, snowy winter last year. Part of the reason for that is suspected to be because there was less sea ice in the Arctic. In fact, record low this past year. And that has to do with this oscillation that occurs in the atmosphere. So some things that seem really remote and are changing dramatically. This is probably the most dramatic example of climate change in the world. It's exceeding the predictions from the climate models. We've lost more sea ice than we thought we were going to lose. And it's actually affecting the Great Lakes. So what can we expect? Well, generally wetter conditions. This shows projections over, or actually real trends that have occurred over the last 20 years or so. And the greens indicate wetter conditions throughout most of the U.S. On the other hand, projected increases in drought severity. I don't have the details, time to go into the details on this right now, but lengthening periods where you have dry days. All right, so the number of dry days, consecutive dry days together. And much of that drought severity is in the western U.S., but you can see that also includes the Great Lakes region. Shifting seasons, so that not all this precipitation is going to come at the same time. The predictions are that we'll have wetter winters, springs, and slightly wetter falls, but actually drier summers. Those shiftings in the seasons are actually showing up in the Great Lakes. This was a study I did back in 2001 showing changes in Lake Erie and Lake Ontario. They're actually rising and falling about a month earlier than they used to. This was predicted to occur about 50 to 100 years from now. It's actually already occurring. That increases in rainfall especially occurs in the very heavy precipitation events. This is the 1 percentile, the highest precipitation events. You can see 45% increases in the Midwest, 74% increases in the Northeast. So these are large changes, and it leads to upward trends in the flood magnitude. Those green upward arrows are indications of increased runoff in streams. Projected changes in Atlantic hurricane frequency by category. Why am I talking about Atlantic hurricanes? Well, they actually impact the Great Lakes. Category 4 and 5 hurricanes are projected to increase in, by 2100 by about 75%. And you only need to look at last year to see that Sandy impacts the Great Lakes. We also know there was hurricanes that, for example, Hazel impacted Toronto in 1954 with significant flooding. There's numerous examples of these landfalling hurricanes that do make it into the Great Lakes and lead to flooding, and we should be concerned about the projected changes in intensity. So extreme rainfall, impacts on stormwater infrastructure. These are some examples from around different parts of Canada. You can see impacts of that extreme runoff on Lake Erie. This was a publication just this past spring that came out showing the record runoff in 2011 that led to algal blooms in Lake Erie, partly caused by agricultural trends, but also meteorological trends. And of course, land use plays into this as well. We have climate change going on, but we've also got changes in land use. This shows an example for the Don River watershed in Toronto, showing the percent impervious surfaces and that increase through time. Well, we have that on top of climate change, and you can get some significant runoff problems. The company I work with in Ann Arbor has been actually working to provide a river wetland restoration plan that tries to naturalize things better and includes some adaptation for things like low base flow and flashier hydrology. So final thought, this is a sign from a spot on Madeline Island in the Apostle Islands on Lake Superior. You're either part of the solution or you're part of the precipitate. So it's funny, I guess, to the chemists, to the meteorologists, and to anybody that lands on the island. That's one of the first things they see. But what we have here is the graph that shows the actual warming and the comparison with the climate models. And then on the bottom, what happens when you take anthropogenic forcings out of the climate models. And so that's where we could be right now if we hadn't been putting fossil fuels into the atmosphere. And people like to use this as playing the blame game. So humans are to blame. Well, we are the cause, but we can turn it around and look at it as a positive. If we can have that much of an impact on the Earth's climate unintentionally, think what we can do when we actually intentionally try to do something good. So my point is, we can be part of the solution, and let's help chart a new future for the Great Lakes. Thank you.